Well, hello everybody. Welcome to AP Physics test review here today. Here's a question for you. Can you tell me the momentum of a mass that's 100 kilograms traveling at 30 meters per second? Can you tell me that momentum? (300 Newton seconds). Who agrees with that? Kilogram meters per second is usually the label for momentum. Newton seconds is the same thing, but we usually use that for impulse. Okay, so you can get number one right on the test. 3,000. Okay. Hey, let me ask you this. Let's just say that you are on a skateboard and your V sub naught is 0. And let's say that you throw a ball that has a mass of 2 kilograms, and let's say that the velocity of that ball is 10 meters per second. Can you tell me the velocity of you? Yeah, the skateboard is 2 kilograms, and the person is 100 kilograms. Can you tell me the velocity of you? There's no friction. Okay, so Kaylee came up here and she did this math problem for us. This was her first equation. She has M1V sub naught 1. And really the part that you forgot is M2V sub naught 2. So that should be here too. If you're gonna start with this, you should really have both of the masses and velocity. But then she's solving here for V2. Saying that that is the velocity of the person and I'm sorry, this is just her algebra related to this first part here. So here's the next line of algebra because we got that signified with the equal sign, and she's solving for V1 here. And this cancels out here, and this would be if you would have signified the initial velocity of the ball as well. That would cancel out here too because it's 0 in the beginning, right? And so multiplying the velocity of 0 times any mass is going to give you 0. So then we're left with the unknown velocity of the person then is equal to, but opposite direction of the momentum of the ball divided by the mass of the person. And notice, because she followed her signs and put her signs in correctly, she did get a negative number for velocity. And since in the beginning we said that this direction was positive, that's why she did her algebra, we should have a negative number. So that was exactly right. Very good. So can you do that for the test? Well, Kaylee can. Okay. Again, thank you, Kaylee. So now we have a ball with 2 kilograms, this medicine ball, and it's moving at 10 meters per second, and it runs into a big pile of hay where it comes to rest deep in the pile of hay over a distance. And it took, let's just say that it takes 0.5 seconds for the haystack to stop that ball. My question to you then is, what's the average force of the haystack? Okay, so Joe came up here because he thought that he could do this one. So if you look at what he did, he said, first of all, I just figured out what the momentum was of the ball, because you need to know what the momentum is, because that, when it comes to rest, there's going to be no momentum. So the change in momentum is equal to the initial momentum, right? But in the opposite direction, right? So he figured out the momentum was 20 kilogram meters per second. He was right about that. And he put out his formula. Impulse is equal to change in momentum, which is equal to a negative 20 meters per second, because final minus initial, you get a negative 20 out of that. And impulse is caused by a force applied over a period of time. So then with that change of momentum of 20 Newton seconds, he could divide that by the amount of time that it took that change to occur, and it comes up with an answer of 40 newtons in the opposite direction of the initial velocity. So this was considered positive, so this force is considered negative, and he showed that right there. Way to go, Joe! Okay, so now we have a rocket question. We have a half-kilogram rocket, and we have one E9 engine. And the question is, what's the total height achieved neglecting air friction? The total height of this rocket achieved neglecting air friction. Can you do that? Okay, so, the total net impulse, or you could say summation of impulses, I suppose, is going to be the summation of forces times the time. So in this case, the summation of forces, well, we have an average force coming out of this engine of 10 newtons. Anybody wondering how I got that, or do I need to show the math for that? Okay, so we've got 10 newtons up, and then we've got the force of gravity 5 newtons down. That should be bigger. So our summation of forces that would cause this mass to accelerate is 5 newtons. Any idea or any questions about how I got that? Okay. So then the summation of impulses would be 5, because that's the summation of forces, times 1.7, and that then equals 8.5 Newton seconds. Okay, and so 8.5 Newton seconds then equals the change in momentum, which we started with a 0 velocity. This way we're going to figure out our final velocity. So divide both sides by the mass, 0.5. So the final velocity is 17 meters per second. Okay, and so we're going to achieve a height here according to that acceleration. So x is going to be equal to 1/2 at squared, or you could say x is the average velocity during acceleration, which is 1/2 at. Or 17 divided by 2, that's actually what 1/2 at is, right? We talked about that. And then the t is 1.7 seconds. So my total height during the burn then is going to be... So the question is, why don't we square the t? Well, I start out with this formula, but if you remember, this formula actually comes from this situation, which is average velocity is final velocity divided by 2 if you start at a 0 velocity. Does that make sense? And that final velocity, acceleration, v equals v sub naught plus at. So v equals at. So then your average velocity equals at over 2. So that's why I said this formula, but in my head I'm thinking average velocity, which I end at 17, start at 0, my average velocity is 17 divided by 2. Okay? So it's been a while since we talked about that, but that's where that formula comes from. So 14.5 meters, but I don't stop there, right? Because I have still a velocity that's going to take me even higher. Okay, so my average velocity now is going to be 17 divided by 2, right? So for my displacement here, it's average velocity times time. 17 divided by 2, because I stop at 0, my high point. And my time then is 1.7 seconds. So what do I get for that? Okay, so it turns out, you guys, that this then becomes the same height then, right? But this is out of the ordinary. It just so happened that this burn time ended up being, and because of the mass of the rocket and things, we ended up achieving a velocity that will take the same amount of time to go down to 0 as the burn time. So please don't think that this is going to happen on the test. So the total height achieved then would be 29 meters. Can you do that for the test? Okay. Okay, here's the next question you're going to ask. So you got, initially we have the top picture, and then finally we have the bottom picture. So it's all about initial momentum equals final momentum. And initially we have 20 kilogram meters per second in that direction. And we have 15 in that direction, right? So, and that's going to equal what we have in the end. So now we have, in the end, we know that we have 15 in that direction plus 2v. Did I write that correctly? Okay, so it's going to be 5 equals 15 plus 2v. A negative 10 equals 2v. V equals negative 5 in the negative direction, which we determined right here as being in this direction. So the velocity is negative 5 meters per second. Can you do that for the test? Okay, so a glancing collision. So this ball is going to strike this ball. And then in the end, we have the second ball, we have a velocity. We need to figure out the velocity of the first ball. So, momentum in the x equals momentum in the x, so not. So let's look at our x velocity, or our x momentum. So the first one is we have 5, and it's in this direction, right? Because 1 times 5, and that's all we have. So in the end, that's all we can have too. Okay, so I'll call this P sub naught, and this will be final. Okay, so in the end, this is going straight down, which means this whole momentum is wrapped up in this ball. Okay, so we know then, if we are using this picture, that this is going to be a value of 5 kilogram meters per second. This part of the momentum. Any questions about that? Okay, so if you look at this, there was no y momentum initially, was there? So whatever this is, which happens to be 2 kilogram meters per second, that's what the momentum is. That has to be then here. 2 kilogram meters per second. So now we have the 1 kilogram ball, we have the x momentum of 5, and then the y momentum of 2. So now we can figure out the actual momentum. A squared plus b squared equals c squared. So the actual momentum is the square root of 29 at an angle of 21.8 above positive x. Okay, but we're actually looking for the velocity, right? So if momentum is mass times velocity equals the square root of 29, the velocity then equals the square root of 29 divided by 1. So the velocity is actually the square root of 29 at 21.8 degrees above positive x. Can you do that for the test? Okay. Okay, so the answer is, and so this ball runs into another ball right here. Okay. And we'll have to give these balls some masses. So we'll say this one is 2 kilograms. We'll say this one is 3 kilograms. And we'll say that the velocity after the collision, so after 2 strikes 3, there's going to be a velocity of 0.1 meters per second for ball number 2. Okay, so that's what the givens are, and the question is, what's the spring constant? Okay, let's see if we can do that. Okay, so we need to figure out what the velocity is of the 2 kilogram ball first, right? And that's going to come out of a kinetic energy. So our change in potential is going to turn into kinetic. So mg delta h is 1/2 mv squared. So our velocity of this ball here is going to be equal to the square root of, cancel that mass out, 2g delta h, which in this case is 0.5 meters. Do you agree with that? Okay. So that's going to be the square root of 10 is the velocity of that first ball before the collision. Okay? So then we have a collision, and this is going to be inelastic collision, right? So now we have to figure out the velocity of that ball, right? So at this point, then we'll take our, momentum initial equals momentum final. The first initial would be 2 kilograms times the square root of 10. And that's my total momentum in the beginning, because this velocity is 0 initially. So that's going to equal the m1 momentum, which will be 0.2, right? Because 2 kilograms times 1, that's the velocity, right? And notice it is in this direction, so it's still a positive number, plus 3v. So the velocity of the 3 kilogram is going to be 10 times the square root of 10. Unless I did my math wrong. I did my math wrong. I'm subtracting 0.2, which I think I made that mistake yesterday too. So it would be 2 divided by, or 2 times the square root of 10 times 0.2, all divided by 3. And that's my velocity of my 3 kilogram, right? Oh. Minus 0.2. 2 times the square root of 10 minus 0.2, all divided by 3 is my velocity. Okay, so now I can say that my kinetic energy is going to equal my spring potential. Do you agree? So my 1/2 mv squared equals 1/2 kx squared. Cancel out my halves. My k then is equal to mv squared over x squared. And after that, it's just filling in all the blanks, because we have the mass of the ball, which is 3. We have the velocity. And then the displacement of the spring is given as 0.1 or 0.2 meters. Can you do that for the test? Okay. Hopefully that helps you with the test. After that, it's just a bunch of multiple choice and one more free response, it looks like. Okay, have a great day. Thank you.